Okay, so try to keep this relatively short. If you're following along in the book now, you need to read the next section in chapter 7, so 7.3, 7.4, I'm sorry, 7.3 you should have already read. 7.4 talks about passing arguments to functions by reference, and that's where our pointers come into play. So that's about 1, 2, 3, 3.5 pages or so, and there's plenty of sample code in there to look at. So not only read the chapter, take a look at that sample code. All the sample code has been uploaded into D2L, so you can look at that. I'll also provide 2 files today, one that we'll look at for example purposes in this lecture, and then an additional one for practice. Okay, so same as last time. It's going to have the solution in it, so you can kind of reverse engineer it or kind of work it in reverse, delete the solution, implement it yourself, and that gives you the ability to practice that. If you have any questions, let me know. Send me an email or communicate in some way. All I ask is that, because I have about 100 students this semester, if you wait until the last minute to send me an email, there's a good chance that about 30 or 40 of you others are doing the same thing, and I can only answer so many emails in one day. So I'll do the best I can. I'm usually answering emails all day long, but it would do yourself a great favor and me as well if you look at those early, so that you can contact me early and figure out the issues. That's part of the reason why I'm opening up all the labs in advance, well in advance, is so that if you want to work ahead, you can start looking at that, working on the labs, and then working with me to get through some of those issues that you may have. Okay, so into the content then. There are 2 ways that we pass arguments. One is pass by value and one is pass by reference. Now, pass by value is something that you've been doing all along. That's what you've learned in 150, and so that is nothing new, or at least it shouldn't be. At this point, you should have talked about pass by value and pass by reference, and probably not gotten into pass by reference, because you're going to use pointers to do pass by reference. But it should at least have been mentioned that there are 2 different ways, these 2, pass by value, pass by ref, and that you're using pass by value. When we pass by value, how you know the difference between the 2 is that when you call a function and you provide values to the arguments. If you're providing a value directly, you're passing by value. If you're providing the character C or an integer value 5, if you're providing a direct value, you're passing by value. When you're passed by reference, then you're providing a memory address. Okay, so just like when we assign a memory address to a pointer, you can pass a memory address as an argument to a function. Okay, and that's your pass by reference. There is one exception, and that is arrays. And if you read the book, you'll see that arrays are actually passed by reference. And what happens is that when your program gets compiled, it automatically converts that pass by. It looks like you're declaring it pass by value, but it automatically converts that into a pointer. Okay, so we'll look at that a little bit later. And that when you define an array as an argument, it is really just a memory address. And when we look at using malloc, we'll see that all elements, an array is just a continuous block of memory. Okay, so those memory addresses will probably make a little more sense then. Big picture, why do we pass by reference? Well, it depends. Oftentimes it's a safer way than declaring a bunch of global variables, especially as a program grows larger and larger. Performance-wise, though, is usually where we look at this, and it does save overall an overhead in the program. Now, it's kind of hard to see that because we're writing a bunch of very small programs. Even if we get to some of the sample programs that we'll look at and work with at the end of the course, which are going to be closer to 500 lines of code, that's still a really small program. So, performance isn't such a big deal. We also have a lot of power in the systems that we're working with, so we don't always concern ourselves so much about memory, how much we're consuming, and can we shave off an extra byte or 2 here as we're fine-tuning and tweaking our programs. It is still a big deal, though, depending on where you write code for. You might still be writing code for a defense contractor for systems on the F-22, and even though they'll have plenty of memory, they're still going to be, it's going to be a lot tighter than worrying about my desktop PC that has 16 gigs of RAM. So performance is a big one. It reduces memory and it reduces processing time, and that is that it reduces memory because once you declare a variable, you've declared it. Memory's been allocated for it, and so when you pass by reference, you're just passing the address for that variable. Okay, when you pass by value, then you create another instance. You essentially create a copy of that variable. So now it's consuming the same piece of information, the same direct value is now consuming 2 different memory locations in the system. So as you can see, as a program grows, and maybe you have a program that's millions of lines of code, it becomes more and more important to determine the best and most efficient route to declare and use your variables. It also reduces processing time. Okay, again, pass by value, if you have an integer variable and you pass it as the value to a function that has an integer argument, then the system has to create that space, essentially a second copy of that variable. It has to create the copy, allocate the memory for it, and then assign the value. So it just takes a little bit more time. Okay, we're talking fractions of a millisecond probably, and there really is no way, at least in 250, that we can appreciably performance test our programs. But as programs grow, these things do have an impact. All right, so let's real quick, when we look at, I'm going to look at some code here after we go through these slides, and we'll take a look at two functions, and I called them loosely based off of the material in the book. I called one cube by value and one cube by reference. Okay, and so we'll look at a function that takes that does pass by value, and then one that does pass by reference. Okay, in the screen capture here, you can see this is here's a function. It has a return type of integer. It's called generate random, and it has one argument, int scale. Up in main then, okay, so just assume those three dots on lines 48 and 53 represent that's a fully implemented function or program. That's our main function, and we declare a variable called scale. We assign a value of 20, and then when we call generate random, we're providing the value of that variable. So we're providing a direct value, the value of scale, which is 20. When we look at this function then, it's not implemented, it's not doing anything. We have looked at random number generation functions, and so you can fill in the dots there. But this then becomes, in essence, a locally scoped variable. It gets created again when that function is called and executed, and whatever value we passed in this function gets assigned to this variable. Okay, the fact that this is called scale and this one's called scale, so the function argument is scale, and then this locally scoped variable is called scale, doesn't mean anything. Okay, the only thing that matters is that they're both of the same type. They're both integer, so that when we call this function, we provide the correct type. In this case, okay, how do we get a value back from this function? Well, when we've used our generate random functions, when we want to get a value back, we return it. Okay, that's why you see the return type here is int, because scale, we're passing by value. This is now a new copy of it. It uses that value. If we change a value inside of here and it's passed by value, we don't change it in the function that called it. Okay, passed by reference though is a little bit different here. We'll take a look at that. So similar code. Okay, here's the screen capture. I'll go back to my slide view for everyone. We just declare an argument as a pointer. Okay, and then once it's declared as a pointer, inside that function, we use it like we have learned now to use pointers. We dereference it. We can dereference it to get the value. We can dereference it to update the value. Let's see. So here, let's take a look at that function. All right, so this is the same basic concept here as far as the screen capture goes. We have one function. It has a return type of int, but that's no longer needed. Okay, and when we look at our cube functions here at the end of the slide, end of the slides here, I think that'll clarify it even further. We have a second argument, and we declared this as a pointer. We know it's a pointer because it has the asterisk in here. Okay, so just like we learned how to declare a pointer in the last lecture, we do the same thing as a function argument. Okay, declaring a pointer as a function argument is no different than declaring an argument in any other sense. Okay, we just happen to declare it as a pointer. So if it's a pointer, then when we call this function generate random, what do we have to provide it? Well, this has two arguments. The first one is expecting an integer value. The second one is expecting an integer, the memory address of something that points to an integer value. So we call generate random. The first argument is passed by value. We have our scale variable has a value of 20, and we pass the value. Okay, so that works just as a previous example. But the second argument is a pointer. So we need to think of it in the sense of what if I was to declare this as a variable, not a function argument, but just a variable, what would I need to assign to end pointer here? Well, I need to assign a memory address. The value of a pointer is a memory address. So we declare a variable here, random number. We initialize its value equal to 0, and now we provide the memory address of that variable. Okay, so we use our address operator. Just like we do in an assignment operation, when we say int pointer equals address operator and then the name of the variable to get the memory address, we do the same thing. Okay, so we call the function, and you can think of this, the values that we provide as these function arguments are what get assigned to these variables, these function arguments, right? So address of random number gets assigned to end pointer. right? And now inside of this function, whatever code we write, we use that as a pointer. Okay, we use that same asterisk character. We dereference the pointer. We can use the value or we can assign the value. So in this case, if we wanted to pass by reference, and we see that this is our random number. So the whole idea behind this example is that instead of returning the random number, we will use a pointer and assign to that random number in the function. So if we were to fully implement this, and I'll do that here in the example code, we would dereference the pointer. Okay, you see that they're not the same name, doesn't matter. We dereference it and we assign it a new value. Now we don't have to have a return type, okay, because once we dereference it inside the function, it's pointing to the same exact place in memory here as it is here, so random number is actually updated. All right, this last slide here is practice. Don't worry about this because I'll provide you a document or a practice file as I have been, and you can use that. It's essentially the same thing, so you don't need to worry about this last slide. I just forgot to remove it. Okay, so before we start looking at code, I'm going to just tell you about the slight difference here because I can't get into the ILab. There's a tool called Cygwin. I have a document that should help you install it if you're interested. Otherwise, I won't really talk about the installation or setup process here. What this tool does, essentially, it allows me to act like I'm on a Linux machine inside of Windows. Okay, so I'm still inside my Windows laptop, but I'm running this tool natively. Behind the scenes here, I just have a text editor. I happen to use Sublime Text. You can use gedit, you could use Notepad++, you can use Notepad, you can use whatever you want, but this is just what I like to use. All right, so what does Cygwin do? Well, you can see here it looks just like a command line. Slight differences. If I type in clear, I can clear. If I type in ls, I can list the contents of this directory. If I type in gcc, and I'm just going to tap, or I'm going to arrow up. Okay, so you can see here gcc, and then here's the name of the file that I'm going to compile. A backslash with this, that represents a space. Okay, so I happen to choose a bunch of file names with a bunch of spaces in it, and that's just how we're representing that inside the command line. Okay, so same thing, GCC, and then the file that you want to compile. It's a .c file. I compile it. There were no errors, so everything looks good. I'm just back to the command line. I have an active shell or active prompt. The difference here is that I'm on Windows now, so GCC compiled it for Windows. That means that if I want to run it, it's a.exe instead of a.out. Okay, exact same concept. It's a binary that you run. It's a program, but the default in Windows is .exe. The default on Linux is .out. That's the only difference. Okay, otherwise it's the exact same program, the exact same process. All right, so two files I'm going to provide you. This one is going to be under the sample code, and then this file will be the lab that you can look at as far as for practice. All right, so for pointers review, let me save that file. We're going to look at two functions then, cube by value, cube by reference. Okay, cube by value, because we're passing by value, we have to return. If I want to do the cube in the function and then return the value, I have to have a return type of that same value. So in this case, it's going to be an integer value. One argument is an integer value, and I just call this one int value. Okay, prototype for the second function then is cube by reference, because I'm going to use the second argument is going to be passed by reference. It's going to be a pointer. I'm going to dereference whatever value is passed to me, cube it, and then assign it to that dereference pointer. Because I'm doing that, I don't need to have a return type because I'm dereferencing that pointer, so I can update it. I can have a return type of void. I don't have to have a return type. I don't have to return a value out of this function. All right, so here's the prototypes for the two. For this argument, keep in mind here, it's just like declaring a pointer. Okay, the type, the name, and then the asterisk character in between the type and the name. Okay, this makes it a pointer. So we'll look at code by value first. And if we scroll down here, here's our main function. And I'm going to declare one integer variable. I'm going to assign it a value of 3. And this is what I'm going to use to cube throughout this program. So after declaring that, the next thing I do is I call printf. And I say cube by value. We use our format specifier for numeric value. And then, because cube by value returns a value, okay, as a return type of int, I can use that as the argument to my printf statement because it returns a value. So I call cube by value and I provide the value of b. Pass by value, I'm providing the value directly. So this is a pass by value call. That means that the value of B is not changed. So if we look at adding another printf, and let's print the value of B, we'll see what happens after this runs. I'm going to comment this out just for a couple minutes here, just to not get all the output confused. Okay, so we'll call cube by value. We'll provide it the value of B. In this case, B is assigned a value of 3. So when we call this function, we'll pass a value of 3. After we do that, this function will return, and then it'll provide it as the value to the printf. So it'll print off that value. After that, we'll print off the value of B. Okay, we'll just see that B is still equal to 3. We haven't changed anything in that function. So let's scroll down. We'll look at cube by value. Here's our argument. This will match up exactly with the prototype. And all we're doing is returning int value times int value times int value. Okay. If I wanted to, just to help prove my point here, let's say that I do this. Let's say that I return int value and I assign int value a new okay, so let's say I assign it a new value. If I do that, if I assign int value a new value, which is itself times 3, and then return int value, we'll see that this should print off 27, but this will still print off 3. Okay, so let's run this and see what happens. Okay, GCC, and that is called pointers. I changed the file name. Okay, so I just saved it as pointers review for me. I forgot exactly what I called it for you guys, but it's very obvious. Okay, so the program compiles, and I'll run it. Okay, here you can see cube value of 27, but the value of B is still 3. Okay, in this function, this is a pass by value. Okay, so this is a new variable. It has a local scope. It only exists inside this function. When we call this function, we assign it a value of 3. Okay, so even though we assign it a new value, which is 3 times 3 times 3, and then return that, this doesn't affect B. B is still the same. Oops. B is still the same. All right, so now let's look at our cube by reference. All right, one argument, it's a pointer, and our return type is void, so we're not returning a value. When we look at the code then, we'll do the same thing, and we'll print off the value of B. All right, so I'm just going to go ahead and comment that out as well. All right, so cube by reference does not return a value, so we can't use that as an argument to our printf. Okay, so we have to call cube by reference on its own. A function that doesn't return a value, you just have to call it. You don't have to assign. You can't use it to assign to another variable, and you can't use it as the value to an argument to another function. So we call cube by reference because the argument is a pointer. We have to provide a memory address. What do we assign to a pointer? A memory address. When a pointer is an argument, then we have to pass a memory address. So we have our variable B. When we call this function, then we have to use the address operator and B, our B variable. All right. So that gets the value of that variable, the memory address, into the pointer, and that allows the pointer to indirectly reference the value of B, which is 3. So once we call cube by reference, then we'll print off the value of B. And this is, I guess, actually pretty redundant because then I'll just say we're going to print off the value of B. But I just really want to emphasize what's happening inside this function, this pass by reference. So cube by reference, here's our pointer argument. Okay, remember that when you use the asterisk operator to declare a pointer. So in this case, we're declaring it as an argument. But then outside of declaration, we use it for dereferencing. Okay, since we're dereferencing it here, and we're doing that on the left-hand side of an assignment operation, that means we're going to assign a new value to it. On the right-hand side, we're dereferencing it, so that means we're going to use the value of it. So you see that we have the pointer, the value of the pointer, the value that the pointer is pointing to. That's what dereferencing gives us. So we have 3 times 3 times 3. Okay, we're not returning anything though, but because we're dereferencing that pointer and updating its value, the memory address was the memory address assigned to the variable b, so we're pointing to the same place in memory and we're actually changing the value there. All right, so we'll compile that program again, clear the screen, and we'll run our compiled program. And there's your output. Okay, the cube value is what we want. It's 27, but that also changed the value of b. b is now 27. Okay, we saw that now in our program twice. There's b, there's the value of b. I mean, we printed it off in the same way, but since we dereferenced b in this function and assigned it a new value, that changed the value of b. This variable had the memory address assigned to it. We passed that memory address to this function, and then we dereferenced it and changed it. So now this value has changed. All right, and that's the big difference between pass by value and pass by reference. Remember, pass by value, if you're providing a value directly, then it's pass by value. If you're providing a memory address or an array, it's pass by reference. All right, the second thing then, and this is just there for your benefit. Here's a program. Here's the to-do. So look into this program, and if you want, this is the solution essentially. So if you want to implement it, delete this function and then delete its implementation, and then work through the code and try to figure out what it's doing. In this case, I say declare a function with 3 arguments: an array, an integer, and a pointer. Right, and that's what we do. And so what this function will do is it's going to compute the average of everything in the array, but then it's not going to return the average. It's going to dereference a variable, dereference a pointer, and then update the value that way. So you can see the return type is void. Here's our compute average. This is how we define an array as an argument. This is just a simple integer variable. And then here is a pointer that's going to point to a float value. All right, in main, okay, just arbitrarily define an array of whatever size with however many values you want. And then here is the variable that we're going to eventually update with the value of the average. So once we do that, we can call compute average, pass our array. When we pass an array, we just pass the variable name of the array. Okay, so A is our array, so we just pass A here. That's actually a memory address. The value of A is a memory address. If you printed that off, you'd see, and we'll do that later on. Here's an integer value. In this case, I use that define size 5, so that'll just be replaced at compile time with the value 5. And then the pointer. Okay, so here is the AVG variable. So in order to pass that as the value to a pointer, we have to use the address operator to provide the memory address. What do we assign to a pointer? A memory address. The value of a pointer is a memory address. All right, you can see because this function is void, it doesn't return anything. We just call the function, and then we have a printf. The computed average is, and we print off the value of AVG. Okay, so if it worked, if you implement it correctly, AVG, because this array has a bunch of values and the average of that is not going to be 0, this is initialized with the value of 0. So when you print this off, you should see something besides 0. If you look at the function then, okay, very simple. Here's our increment counter. Here's our sum variable. Here's a loop. Okay, this is how we add the value of every element in an array into one variable. And then here, instead of returning that, I just dereference the AVG variable. Okay, that's the argument, that's the pointer for a third argument for our function, and assign it a new value. So when this program runs, you'll see that I think it's the value of 3. 1, 2, 3, 4, 5 are my elements in my array. So we'll go ahead and I'll just run that real quick. Pointers. Okay, computed average is 3.00. All right, and that's it. So read the book, section 7.4, listen to the lecture obviously, and then work through any of the sample code or practice that I provide, and let me know if you have any questions. Thanks.